Hello everyone! Today we're going to be doing some practice with the stoichiometry of neutralization, and I'll try to use the same structure I did in the main video, and we'll see how that goes. So we have here the volume of sulfuric acid. What volume of sulfuric acid is the question with a given concentration, so that's my concentration of acid, can be neutralized by a volume of base at a certain concentration for that base. And so we're going to think about this. We do have to think about the chemical reaction here. So H2SO4 is getting added to sodium hydroxide to form the sodium sulfate plus water. This reaction happens in a 2-to-1 ratio, and that's going to be really important. So what I like to do is I like to do some sort of organization here, a little organizational chart, and compare the product and reactants and their ratios. So my ratio here is 1 to 2. And so that means that for every mole of the one, I need 2 of the other. So if I have, so let's put moles here. However many moles of acid I have, I'll need twice as many moles on the other side. And then we're going to put volume and concentration. Doesn't really matter here. We're just going to do volume and concentration like this. Okay, so for my sodium hydroxide, I do have a actually, I think in this question I am going to flip them because I want my last thing to be on the bottom. Whatever my last thing is, I want to leave that on the bottom. So this is the box I'm going to try to fill. Okay, so put in all the information I have. Put things in volume in liters. So I have 0.05000 liters of base. I have 0.36 moles per liter of the base, and I can use these two to determine the number of moles by multiplying, because CB times VB is going to be equal to NB, my number of moles of base. So let's do that calculation real quick. 0.36 times 0.0500, doesn't matter to add those zeros, but that's okay. 0.0180 moles. Okay. You could also set this up. I know that a lot of students learned to do these setups this way, so we can treat this as moles for 1 liter. And what we're doing is we're multiplying it by 0.0500 liters, where the liters will cancel out, and that will leave us with that answer, 0.0180 moles. And this is in our base. Now, it takes 2 moles of base to 1 mole of acid. So when we when we want to convert this over to this value, what we need to do is we need to essentially divide our number of moles and divide our number of moles by the given ratio and multiply by the ratio of what we're looking for. And we do this all the time. I've just done it in this strange way, I'm sure. So I'm going to take my 0.0180 moles of NaOH. I'm going to times that by that mole ratio. I have NaOH, so I put that on the bottom, 2 NaOH, and I have 1 H2SO4 in my chemical equation. So I'm going to essentially have it 0.0090 moles. Now that I have that, and I also do have a concentration here, I have 0.24 moles per liter. Now to find my volume, I simply am going to divide away by the concentration. So N divided by C is equal to V. So I'm just moving down. I'm going to divide away this way. So here we had sort of multiplying to go up, and now we're going to have a division to go down. So I'm going to take my 0.0090, probably have a whole bunch more significant figures than that, but that's okay, moles, and I'm going to multiply that by 1 liter divided by 0.24 moles, which is another way of representing this concentration. So that is going to end up becoming a division divided by 0.24. And my value here is 0.0375 liters. So I can't quite neutralize as much acid as I had base, because the concentrations are different and the ratio of acid to base is not 1:1. Okay, let's try this next one. Concentrated hydrochloric acid of this much concentration, so this is my acid concentration, is added to a spill of 7 liters of sodium hydroxide. So that's a volume of a base with a concentration, okay, so that's a concentration of base of this much. Okay, and what volume of acid is required to neutralize the spill? So here we have HCl plus NaOH gives us NaCl plus H2O. So this one is a 1:1 ratio. So I'm going to just kind of split them up. I have a 1:1 ratio. So that's my ratio. I'm going to do my moles here. I'm going to do, in the end, I'm looking for volume. So I usually leave my whatever I'm looking for, I put at the bottom of my table, and then I put the middle one as concentration. And that's just to help me keep track of things. Okay, I'm going to put in the details that I have. So I have a concentration of my base at 2.00 molarity. And I have 5 liters of this stuff, 5.00 liters. And I also have the concentration of the acid at 11.70 molar. So that's some pretty strong acid. That's some nasty stuff. So the first thing to do is to do a concentration times a volume gives a molarity. So we're going to go 5 liters times 2.00 moles per 1 liter. Liters cancel out. I know I'm skipping around on the significant figures, but please forgive me. And that's going to give me 10.0. Looks like 3 significant figures, so that's 10.0 moles. And then I'm going to use this ratio, and I notice here that it is a 1:1 ratio. So however many moles I get here is also equal to the number of moles over here, 10.0 moles. And now I'm going to use this equation N over C is equal to V to find my final value. So I'm going to take these 10.0 moles and I'm going to divide them out by 11.70. You know what? I'm going to try to follow what I know happens in grade 11, which is the ratio method. So there's 1 liter. So we're using an inverse ratio here. And I'll put that down here so we can follow. And the result will be 10 divided by 11.7, which gives us 0.85, 0.85 liters. So if you have 5 liters of a weak base, actually relatively strong base still, but if you have only 5 liters of this stuff, you can't, considering how strong the acid is, you can't really neutralize a lot of it. So you're going to be adding a lot of, you're going to have to add a lot of base to neutralize a little tiny bit of this very strong acid. Okay, I'm going to try to look ahead and see if there's one that's a little bit more exciting. let's see. All right, let's try, that's nitrous acid. Okay, so here's some phosphoric acid again. So that'll be a little bit more exciting because that is an H3. So what is the concentration of a solution of phosphoric acid if 325 mils, so that's the volume, is required to neutralize the base solution of potassium hydroxide? This is concentration of base. Okay, so in this case we have H3PO4 added to KOH, giving us K3PO4 plus H2O. And again, anything with potassium in it is extremely soluble, so you actually aren't forming K3PO4. You're just going to be forming some sort of some potassium ions and some phosphate ions in solution. Okay, we're going to start with that ratio. So let's figure that out. We need 3 of these to form 3 waters. So the ratio is going to be 1 to 3. And what other values have they given us? Have they given us moles? No, of course not. That would be too easy. But they have given us a volume and they've given us a concentration. So here I'm going to flip them. I'm going to put volume next because I like to have whatever's last, and then concentration. So this is the concentration of acid that they're interested in, and everything else has been given to us. So let's figure that out. So we have a concentration of 0.250 moles per liter. We have a volume of 0.250 liters. We have 0.325 liters. And now we simply have to fill in the rest of the details. So first things first is we're moving up in the table. We're going to multiply. We're going to take 0.250 moles per liter multiplied by the 0.250 liters. And so that's 0.25 times 0.25. Well, that's fun. That's like taking 25 squared. So 0.0625, and the liters will cancel out, leaving us just with moles. 0.0625 moles. And it is a 3-to-1 ratio. So we are going to have to divide this by 3 and multiply by 1 because we're going to be taking 0.0625 moles of KOH and we're multiplying that out by the 3 KOH in the equation and the 1 H3PO4 in our equation. So essentially taking 1/3. I'm just going to continue on. And so that's going to give me 0.0208. And that will be moles of H3PO4. So 0.0208 moles. And then I'm moving down in my table, so I'm just going to divide. So I'm going to take N divided by V, which will give me a concentration. And so we're going to be placing, sorry about that, we're going to be placing 0. I'll use the zoom function here, 0.0208 moles of H3PO4 divided by 0.325 liters to give us a value of 0.325, okay, 0.064, and that will be my molarity. Okay, and that goes over here, 0.064. I actually have enough for one more significant figure, so I'm going to put 1 here because I see everything else has 3 significant figures, so I can carry that through. Okay, hopefully that helps you out, and if not, then please hit me up with an email, and we will have a discussion about how to do these problems. Okay, have a great day.